Hi, and welcome to Calic's Sustainable Aquaculture series. In this series, we'll explore different aspects of aquaculture and define key characteristics of a more sustainable approach to aquaculture. Sustainable aquaculture is possible with the right mindset and innovative technologies. Aquaculture is projected to be the prime source of seafood by 2030 as demand grows from the global middle class and wild capture fisheries approach their maximum take. When practiced responsibly, fish and shrimp farming can help provide livelihoods and feed a growing global population that's estimated to reach 9 billion by 2050. In the past, we've made a lot of environmental mistakes on land, and as we increase our focus on fish farming, we are presented with an opportunity to not make those mistakes again in our relatively untouched oceans. But for an aquaculture system to be truly sustainable, there are a few things to consider. First, environmental sustainability, which means aquaculture should not create significant disruption to the ecosystem or cause the loss of biodiversity or substantial pollution impact. Second, economic sustainability. This means aquaculture must be a viable business with good long-term prospects. And finally, social and community sustainability. This is about making sure that aquaculture is socially responsible and contributes to community well-being. In this series, we'll look at various aspects of shrimp culture and at how it affects the environment. We'll look at different measures that can be taken to reduce this environmental impact. Please note that much of what we will cover can also be applied to pond fish culture. Let's start by looking at current practices. Shrimp culture has developed from traditional methods where small populations of shrimp were cultivated to feed local populations with minimal environmental impact, to a more intense culture with high stock densities and a much higher impact on the environment. There are a few common practices for shrimp culture. First, extensive. Second, intensive. Number 3, clear water systems. And number 4, RAS, that's Recirculating Aquaculture System. With the RAS system being a recycling system, it's only really used in China and the West. Extensive shrimp farming is often carried out in conjunction with fish culture. It's often used in small villages to feed local families or communities. This is the traditional method used for shrimp culture. Yields are low, about 50 to 200 kilograms, and there's usually no feeding or aeration. The impact on the environment is usually quite negligible. Intensive shrimp farming is an extension of the traditional extensive culture and is geared to producing shrimp at a larger, more commercial scale. Many of these shrimp farms are traditional earthen ponds, with aeration and chemical adjustments, where feeding is usually done with synthetic feed and drainage, and toxic sludge is commonly drained. This type of culture allows more intensive stocking, between 50 and 100 pieces per square metre. As demand for shrimp increased in recent years, many of these farms have also adapted lined ponds, which enabled them to increase their stock densities up to 150 to 200 pieces per square metre. As stock density increases, the need for drainage of toxic sludge and water exchange increases. This is precisely what, for many farms, poses a major operational issue and thus an environmental challenge. These intensive shrimp farms have traditionally been farming monodon, commonly known as the giant tiger prawn, in Asia, with stock densities of 20 to 30 pieces per square metre. However, in recent years, another species, known as the Pacific white shrimp from South America, has also been introduced, with many farmers making the switch as this species grows faster with great stock density of 60 to 200 pieces per square metre. We hear the same story from many of our farmers across Asia. The first years of culture produce consistent and profitable crops with little instance of disease. However, in recent years, crops have started to decline and instances of disease appeared to be more widespread. The river systems and coastlines in these intense culture areas are often heavily polluted with toxic discharge from farms. We believe this is one of the primary causes of reduction in yield and the increase in diseases. So, why is sludge so bad for the waterways? Well, it's high in COD, that's chemical oxygen demand. This means it affects oxygen levels in the water. It contains toxins like hydrogen sulfide, known as H2S, ammonia and nitrite. They're all really bad for shrimp culture and an ideal breeding ground for viruses and diseases. When this nasty sludge is discharged into the waterways, it can affect the quality of the water, which the farmer needs for his day-to-day operations. So this then becomes a vicious circle, and it progressively gets worse and worse at the lower end of the system. In fact, as waste from farms upstream is discharged, it affects the water quality but also the bottom of the waterway. It's like discharging raw sewage into your system, which means you're introducing unwanted disease and pollutants in your farm. Intensive shrimp farming was based on a green water system where farmers cultured beneficial algae that could supplement synthetic feed, particularly in the early stages of the culture. But in recent years, we've seen an increase in the introduction of clear water systems. In this clear water system, feed water is treated and sanitized in a reservoir, and algae are destroyed or discouraged in this system. And this makes clear water totally dependent on synthetic feed, with drainage of toxic sludge becoming a lot more needed and frequent. This method recommends that all sludge is treated in a further pond system. This clear water system also increases the cost of culture dramatically. It impacts the cost of chemicals needed and reduces the available cultivation area on a farm. Unfortunately, farmers using clear water systems do not always treat the sludge adequately, and it's often discharged directly into the environment to reduce costs. This pollution poses a critical risk to the environment. Let's now have a look at recirculating aquaculture systems, RAS. These are gaining great popularity in China and the West. In this culture method, shrimp and other species can be farmed all year round at high stock densities. Recirculating aquaculture systems are usually highly regulated by the farmer himself, with strict attention being paid to water quality. Water temperature is controlled, along with pH, alkalinity, ammonia and nitrite. Discharge is often regulated by local authorities. All this makes RAS probably the least polluting of the shrimp cultures practiced today. The downside is the high cost of infrastructure, the stringent environmental control and the cost of waste treatment. Of the many systems used commercially, most impact on the environment unless strict controls are applied. Of course, it's the most frequently used systems that pose the highest potential risk for environmental impact, and they are intensive farming and clear water farming. Both of these methods require frequent sludge drainage and water exchange, and as we've seen previously, this can really impact the waterways and the farm's productivity. Clear water, or CP system, is a system where water is sterilised and suspended solids and nutrients are removed from the grow-out area. This means that natural nutrients and minerals are removed. It's an expensive method of farming, as everything needed for the pond to grow must be added by artificial means. And this is why it's extremely expensive in chemical use, power, and is also wasteful on land use. The idea is to reduce the proliferation of disease, but unfortunately, nature abhors a vacuum, which is in fact created when removing beneficial algae. So, if the farmer doesn't sanitize correctly or exercise correct biological protocols, such as stopping birds, insects, lizards and monkeys gaining access to the ponds, or wind and floodwaters entering the farm, there's a high chance that pathogens, virus or fungi are introduced. As there is no dominant species of algae in the pond and free chlorine can't exist in conjunction with the culture, this leaves the ponds open for the proliferation of disease. And it only takes 4 to 8 hours for things to get out of control. In future episodes of this series, we'll investigate how to reduce environmental impact while using shrimp waste and controlling grow-out conditions. So what does this all mean, and what does it mean for you? Aquaculture is a relatively new industry with a bright future, but in some cases it still has a long way to go. Theoretically, aquaculture and shrimp farming can and should be a more efficient way of growing food with less environmental impact compared to land-based animal agriculture. As scientists' understanding of these impacts and risks increases, regulators and farm managers can start implementing strategies to protect their farms and the environment they depend on. With passion and a purpose of solving global challenges, Calyx has developed AQUA-Cal Plus, a water conditioner that safely addresses disease, improves productivity to sustainably meet the nutritional needs of a growing global population. Sustainable aquaculture is possible with the right mindset and innovative technologies. Because, as we like to say here at Calyx, there's only one Earth and it's already ours. Mars is for quitters. Thanks for your attention. We hope you found this video interesting, and I hope you'll join me again for the next episode of this series on sustainable aquaculture. To find out more about us, or about AQUA-Cal Plus, visit our website at www.kaleaks.global.